Well, it's all in most of it is in, if you look at, a lot of them are the same thing. If you look at this right here in your textbook tab, it tells you consistent and what? Dependent, or consistent and independent. Okay, or you have no solution and inconsistent. All right, so if you go back in your textbook, it's on that first, look in your textbook real quick. What page is that? What page number is that on? 333. If you look at that in yellow up above, okay, it has all of them highlighted. What was the one you were looking for? Dependent? Independent? Okay, so definition or sentence you could probably put for that is if a consistent system has exactly one solution that is considered independent. Yeah. Okay, as far as the glossary definition, there may not be one back there, I don't know. Is that what you're telling me? No, if it's blank, just leave it blank. Okay, let's go ahead and get started with the notes, guys. 6-1, huh? You'll need to turn that in before you leave today. Okay? Okay, today's the 7th. No rest for the weary. Okay, did you guys get the objective down? Skills 2.4. Okay, so basically, when we start talking about systems, we've done graphing, all chapter 4, right? When we start talking about systems, we're talking about how many lines? 2 at least, maybe more, okay? A system is basically just a bunch of lines that we put together. Sometimes they are what? parallel, sometimes they're perpendicular, okay? A lot of times we talk about these two lines right here are not perpendicular, but they do what? They intersect, okay? Now, each one of them have an equation, right? That we can graph. The thing that we're trying to find is, we're trying to find that point where those two lines intersect. Okay? Because that point will work for both equations, won't it? Because technically, doesn't it lie on both lines? Mm-hmm. It has to, since it's the what? The point has to lie on both lines because it's what? It's the point where they do what? Intersect. Does that make sense? You guys are out to lunch, some of them. Okay, so also too, if you notice there's just one line shown here. Technically, there's how many lines there? There's two of them. They just do what? Lie on top of each other. Okay? And then you're going to have lines that are parallel to each other, which means they will never do what? They'll never intersect. So there's no consistent solution for both of those. All right? That's what we mean by inconsistent. Okay. Look at this one. Use the graph to determine whether the system is consistent or inconsistent, and if it's independent or dependent. What are these two lines doing? Parallel. How do I know for sure that they are parallel? Yeah, I have to compare the slopes. Slope here is negative 1 over 1, negative 1 over 1. So that would be what? What's my answer to this? Look at your chart, which we just went over. Inconsistent, right? Okay, what about this one? Now, this looks a little tricky. Notice how many equations do you have? 3. You got 3, but it only shows how many lines. So what do you have here? What happens? Got this one right here and this one. There's 2 lines that are actually what? Laying on top of each other. Okay? That's probably the most confusing for people to understand. Okay? So use the graph to determine whether the system is consistent or inconsistent. Look at the 2 equations that they're wanting us to refer to. This one and this one. So where are they at? This one is right here. And the other one is where? Well, does it matter? No, it doesn't matter. Why? Well, if they're laying on top of each other, then they have to be the what? The same equation, don't they? Okay, so these two are going to be what? Consistent or inconsistent? Consistent, okay? And they also have what? They also have what? How many solutions? Exactly one solution. So that makes them what? Dependent? Look at your chart. Independent, I'm sorry. Independent. Okay? So they're consistent and dependent. Okay, solve by graphing. Graph the system in equations to determine whether the system has no solution, one solution, or infinite many. Infinite many would be what? The lines would be, they're going to be on top of each other, right? If they have infinite many, that means that they're on top of each other. Okay? So let's graph these 2 equations. It's probably the easiest way to determine this. First one's real easy. Where do I start at? 3 on the y-axis, and then go up 2, 1 right. Good. It's an equal sign, so it's going to be a solid line, isn't it? Draw some other points here. Yeah. On my desk. I would, if I were you guys, I would highly, highly recommend using a ruler to graph your lines. Okay, so you can see where those two lines intersect, or at least get pretty close. Next line, what do I have to do with it?
You have to put it in the slope and so forth.
Okay, start me off.
Subtracting.
So that would give me -4y.
Equals -8x minus 12. 5 by negative 4. Give me y equals 2x plus 3.
Okay, what do you notice here?
Same one.
We're the same. So what's that mean, Paris? Infinite many solutions, right? They're consistent. Good. Pretty easy, right? So far? Everybody got that one? Okay, graph the system equations, do the same thing, all right? Okay, so let's see. Do the first one, it's going to be -2y equals -1x plus 4 divided by -2. Y equals 1/2 x minus what? 2. Okay, and then -2y equals -1x minus 2 divided by -2. 1 equals 1/2 x plus 1. What do you notice about these two? Do I even have to graph them? Do I have to graph them? What do I know about them right off the bat? Same slope, so they are parallel. Same slope, different y-intercepts, or they're parallel. Are they ever going to intersect? So it's going to be what? No solution. What do we say? That's inconsistent, right? Yeah, it's good to hang out. Okay, example 3. This is how we would apply a real life system. This is probably how you're going to see it on the EOY test also. Okay, Naresh and Diego are riding their bicycles to get into shape. Naresh rode 20 miles last week and plans to ride 35 miles per week. Okay, so what has he already done? 20. He's already done 20, right? So can I start at 20? So that would be my, if I were to put it in an equation, that would be my B, good. Be my starting point, right? And then my slope would end up being, what's it say down there, guys? Let y equal week. Diego and I've written the same number of miles, so the rich is y equals 35. 35 becomes the what? Miles per week. What have we said? Anytime you see that little word right there, what's that mean? It's going to be a rate of change. It's the same thing as slope. All right, so I can use that as my slope, 35 times x, or 35x, plus the starting point, which is 20. And then Diego rode 50 miles already, which is his starting point, and then he's going to do 25 per week. Now, when I get those two, all I got to do, at what point do they become the same? What am I looking for? At what point will they have done the same amount? Is when these two lines do what? Intersect. So now, can you give me a week? Okay, the graphs appear to intersect at the point with the coordinates what?
2, 3, 1, 5.
About right here, so if I follow that down, it's going to be what? 3 is my x, 125 is my y. Goes right there, and then all the way down. Okay, so check this estimate by replacing x with 3, and then 125 in each equation. We don't need to do that. Okay, so how many weeks is it gonna take before they've done the same amount? It's 3, right? What's on the bottom here? Weeks. Time is always mostly, time is on the x coordinate. That's what we're looking for. Now really, the only reason I would plug it in just to see what, check for equality, see if it's a true statement. Huh, nice. Okay, do you guys have this one?
Yeah.
In your notes? Okay, good. This one is very similar. This is very similar to the one that we just did. Okay, Alberto and Shante are reading a graphic novel. Now notice, how many people do you have? You got 2 people, right? Okay, anytime you have 2 people that are doing the same thing, it's usually going to be how many equations? 2, which means it's going to be a, what are we doing today? A system, right? Okay, it's going to be 2 equations. So write an equation to represent the pages that each boy has read. So Alberto did what? 35, and then he's going to do 20 each day. So what's my rate of change here? Okay, so I'm going to say y equals 20x plus 35. The Shante is going to be y equals what? There we go, 10x plus 85. Then we can graph each equation. What do I need to go by down here? What do I go by? It says each what? Day. So on my x and each, do I go by 1s or do I go by 2s? How do I know for sure? What did we say? Check your what? What's my slope? 20 over what? 1, and then 10 over. So my count on the bottom needs to be what? We need to go by 1, don't you think? Because my run is 1, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go by 1s on the bottom. That makes my count, when I count my slope, does that make it a lot easier? Yeah, okay. And then on the y-axis, I'd go by what? You go by 5s. I'd probably go by, since I got 10 here, and then 20, I'd probably go by what? 10s, right? Because it's got to go higher than, I got to at least get up to what? 85, don't I? Okay, so that first notch is going to be 10, 20, 30, 40, 50, 60, oops, 70, 80, 90. Now I've gotten up to my 85, haven't I? That's my highest number there. Okay, so I'm going to do this guy in red. Start where? Which is right there. Now remember, when you count your slope, you got to do what? We're starting halfway in between, so when I count, I got to go where? I got to go up 10, don't I? If I just go to 40, how many is that? Hello? You guys paying attention? Winston, are you paying attention?
Yes.
Don't look like it. Looks like you're messing with your fingernails. How high do I got to go here? Do I just stop at 40 or do I go in between 40 and 50? I got to go up 10, don't I? Or do I go up 20? I go up 20, don't I? So I got to go 5, 15, and then 20 is right there, and then 1 square there. And then we'll do the other guy in blue. So we start at 85. Go up 10. Go up higher. All right, in there. So how long will it take before Alberto has read more pages than Ashante? Well, when are they going to be the same? Probably about 4 to what? 5 weeks. Okay? Because what happens, the red line, is Alberto does what? He takes over. And then he goes more, doesn't he? Once he takes over here, then he gets higher and higher than the other person, Alberto, or Ashante. Everybody see how we interpret that data? Okay. Okay, go back and do your mastery. Okay, determine how many solutions there might be. First thing we got to do is what? Change up these equations. That's going to be y equals negative 3x minus 3. And then the second one is what? Y equals minus 3x plus 3. Do I even need to graph these two?
No.
Tell me why.
Very well.
Okay, so that means what? No
No solution.
solution. Good. Okay, second one, what kind of line is that going to make right there? Horizontal, where? So 1, 2, or 1, 2, 3. Okay, then the other one. Negative y equals negative 2x plus 1 divided by negative 1. Two x minus 1. Where are these two lines going to intersect? How many solutions? One. What is it? What's the solution? Okay, negative 1 and negative 3. One solution. Okay? Guess how many problems with these other two? Do you want me to work them? Anybody want me to work them?
Yeah.
Okay, where do I start on the first one? Up one, right one? Same equation, isn't it? So it's how many solutions? Infinite. I don't know if that's going that right. So, what do you know about these two lines? Where are these two lines gonna be? Perpendicular, right? So are they gonna have a solution? Where's it gonna be? You guys see what I'm doing though? When I counted my slope, what did I do? Did I run into the other line? Okay, so what's that point going right there gonna be? 2 and that's your solution right there. Pretty easy, yeah. Okay, look on the back side. Look on the next page at box 1. How many equations do you have there?
5.
How many lines do you have?
3.
4. Looks like 4 to me, right?
Yeah.
How many equations do you have? Okay, so one of those is probably what? Laying on top of each other, right? Okay, so don't let that trick you.
That's what I thought. Everybody here today? Who's not here? Because they want to split up.
I don't even know what, I'm pretty sure it's not there. I think that is.
That's what I'm going.
But you said that it was.
I was walking the line and
Yeah, that's
you have to walk.
Yeah.
Make sure. She can be in stand up straight. She was she saw my father and then it's great. I Was our first home source our last one? It was our first one. I can't remember. No, our last was first one. Yeah, I saw them.
You can bring it to me or turn it into the basket. I don't care. Thank you. Bring it to me. Who's she? Who? Okay.
Did you grade our test corrections or no?
I'm working on it. I've got
Do
like
you know when?
4 classes
Okay,
and
that's fine. I understand.
between baseball and teaching class.
Yeah. Do you know when like grades are getting put in like before breaks?
That's my goal. I'm gonna try.
Okay.
I'm gonna try to get all the tests. I'm gonna try to at least get all the test corrections done prior to us leaving for break,
Okay.
and then just try to piece in like some of 6 also as we go.
May I have a part this hour?
Sure.
Okay, thank you very much. I've done quite a few lessons. I don't know if the other kids have done, but we have.
Okay, it's the first bell ringer. As soon as you get it, make sure you put your name in the top right-hand corner. Today's date, 3/7/2016. Want you to omit number 3. X out, cross out number 3. Omit number 3.